Ayan. So, good day everyone. Welcome to this subject on microprocessor and microcontroller systems. So, for this lesson, we'll be discussing uh, an introductory part on microprocessor, microcomputers, and assembly language. Ayan. Ano ba yung focus natin dito sa microprocessor, microcomputer, and assembly language? So, for this first part, um, kailangan ma-appreciate natin ano ba ang microprocessor. So we'll be drawing a block diagram of a microprocessor-based system and explain the functions of each of the component. So we have the microprocessor, memory, yung input-output, and their lines of communications, katulad ng bus. So we shall also describe or explain ano yung SSI, MSI, LSI, and we should be able to differentiate ano yung bit, byte, word, instruction, what is a software and hardware. And also, we'll be able to explain in difference between um, the machine language and assembly language of a computer. Uh, Siguro, i-explain na rin natin ano ba yung ibig sabihin ng low-level languages and high-level languages. Okay? So, and then, once na ma-differentiate natin yan, we can now then explain ano yung advantages ng assembly language over dun sa mga high-level languages. Okay. Then siguro i-define na rin natin ano ba ang operating system and should be able to draw a block diagram of an example of a system which uses microprocessor controller. Okay. So, ano ba ang microprocessor? Okay. So, a microprocessor in general is a multipurpose, programmable, clock-driven, register-based electronic device that reads binary instructions from storage device called memory. So the microprocessor accepts binary data as input and processes this data according to those instructions and provides results as output. So we have here a block diagram showing um, what uh, the basic configuration of a computer, no? Uh, which has a microprocessor as its central processing unit, and it has a memory and input and output. So, ayan. So, medyo mag-discuss lang tayo ng konti dyan. Meron tayong dalawang klase ng applications. So, yung mga microprocessor applications, they are classified primarily into two categories. Meron tayong tinatawag na reprogrammable systems and embedded systems. So para dun sa mga reprogrammable systems such as microcomputers, yung microprocessor ginagamit natin sa pag-compute at data processing. So ang examples niyan ano ba? Yung mga ginagamit natin mga general purpose microprocessors katulad ng yung mga CD-ROM. Yan. Let's say printers. Yan yung mga reprogrammable um, applications. Katulad ng PC or yung personal computer. Sa amin sa mga examples. Para naman sa mga embedded systems, the microprocessor is a part of the final product. And ito, hindi siya available na ma-reprogram ulit. So yun yung difference ng reprogrammable applications and yung yung embedded systems. So an example of embedded system, yung photocopying machine, for example. 'Di ba? Hindi na natin nagagalaw dahil naka-program na siya. Yun na yung kasama na siya sa final product. Okay? So that's the difference between reprogrammable and embedded system. So the microprocessors used in yung mga embedded system, meron tayong dalawang klase. Una, yung microcontrollers, And then yung pangalawa, yung general purpose microprocessors. Okay? So yung mga embedded system, they can be viewed as products that use microprocessors to operate or to perform yung mismong operation ng product. Hindi katulad ng reprogrammable computing and handling of data. So ganun siya. Napakitandaan. Sa mga example siguro ng mga embedded system, yung mga automatic washing machine, yung mga dishwashers, yung dashboard sa sasakyan, traffic light controllers, yan yung mga example ng mga embedded system. Right? Okay. So next, microprocessor operates in binary digits. Pakitandaan yan, the microprocessor always operates in binary digits. 0 and 1, we call them bits. So each microprocessor recognizes and processes a group of bits called word. So yung microprocessor kaya niya makarecognize ng word. So kada microprocessor, they can be classified according to their word length. Meron tayong mga 8-bit microprocessor, 16-bit microprocessor, 32-bit microprocessor, and so on, 64-bit, ganun, diba? So we have here a traditional block diagram of a computer, no? So meron tayo diyang input na papasok sa microprocessor natin and external memory. So yung microprocessor natin dito, we have two parts or two components. Yung first is yung arithmetic logic unit or yung ALU. Tapos meron tayong control unit. So lastly, meron tayong output. So ano man ginagawa niyang mga yan? So para unahin natin yung memory, no? Yan. Yung memory natin, para yung pages ng notebook. So meron na tayong mga lines, di ba? So kada line sa memory natin, kaya niya mag-store ng a fixed number of binary numbers. So depende yan dun sa structure ang pagkakagawa ng ating memory. So for example, meron tayong 8-bit register, can only store 8 bits, 8 binary bits, no? And meron din namang laman yung memory na yan, ng mga registers, kung saan ginagamit natin to store yung mga bits na yan. Okay? So itong mga registers na yun, na to, they are always grouped together in powers of 2. For example, a group of 1024 na 8-bit registers on a semiconductor chip is known as a 1K byte of memory. So it doesn't mean na 1,000 siya. So ang laman talaga niya is 1024. Okay? And then yung user, susulat tayo ng mga instructions dito sa memory, dito ini-store sa memory. So pagka mag-execute na ng program si microprocessor, dito niya hanapin yung ipaprocess niya. Okay. Then next, meron tayong ano pa ba? Input and output. So yung user natin can enter instructions and data papasok sa ating microprocessor at sa memory using yung mga input and output devices. So pagpapasok, input, for example, keyboard, kaya mga switches. So tawag natin dito input devices. Wala yung pinakaiba sa mata at sa tenga ng katawan. So yun yung mga input natin, yung mga senses natin. At the same time, the microprocessor reads these instructions from the memory and then processes the data according to our instructions. And then yung result na yun, ng processing na yun can be displayed, for example, sa isang LED or 7-segment o kaya pwedeng ma-print sa printer. So ang tawag naman natin doon yung mga output devices. Okay? So punta naman tayo dun sa part ng microprocessor. So we can also view the microprocessor as the primary component ng isang computer. So, it contains yung CPU, contains various registers to store data, and then meron tayo diyang arithmetic and logic unit to perform arithmetic and logical operations. Minsan nagde-decode tayo ng mga instructions, then merong counters and control lines. So yun yung ginagawa ng ALU or yung ating arithmetic and logic unit. Um, yung CPU natin is the primary and central player in communicating yung mga devices natin such as memory, input and output. However, kailangan din na synchronize yung operation. Kaya meron tayo diyang CU or yung control unit. Ito yung bahala na mag-synchronize or mag-timing ng mga communication processes inside the microprocessor. So kailangan niya control unit to do the timing. Okay? Sa practice, yung term ng microprocessor and microprocessor unit, ano yan, they go hand in hand. They are used synonymously. So pag sinabi nating MPU, it implies a complete processing unit with the necessary control signals. Okay. So meron din tayong tinatawag kasi na MCU. Pag sinabi naman nating MCU, yun yung microcontroller unit. So base nga doon sa diniscuss din kanina, a microcontroller is essentially an entire computer on a single chip. Isang buo na siya. No? Sama na doon yung input, output, and then memory. So, yan. So dahil sa advances sa semiconductor, mas na-improve natin yung efficiency ng mga microprocessors. From the year 1960, yung nagagawa lang natin sa isang chip, less than 100 transistors. Pero dahil yun nga, nag-advance yung technology natin sa semiconductors, we can now actually place more than 1 billion transistors sa isang chip, no? So that is according to Moore's law. So every 2 years nag-increase, nagdo-double yung kaya nating ilagay sa isang chip. So meron tayo dito yung mga integration levels tulad ng SSI or small scale integration. Yung transistor count niyan sa isang IC less than 100. Then meron din tayong medium scale integration or MSI. So from 100 to 300 yung range ng transistor count. And by 1975, meron na tayong LSI. So umaabot na yan ng 30,000 transistors sa isang IC. And 5 years later, in 1980, kaya na mag-manufacture ng mga VLSI. That's 1 million transistor counts in a single chip. And by 1990, more than 1 million na. So we call it the ultra large scale integration or ULSI. And by the year 2010, more than 1 billion transistors can be placed inside an IC chip. So we call that the gigascale integration. Okay? So dito naman sa left side ng ating presentation, we have here a block diagram ng microcontroller. A microcontroller is essentially an entire computer in a single chip. Isang buo na yan. Nandiyan na yung input-output, yung kanyang CU, ALU, timers, and yung GPIO, General Purpose Input-Output. Nandiyan na rin yung mga yung analog to digital conversion processes or processing units. Kasi isang buo na siya, no? Kasama na siya dyan. Okay? So yun yung pinagkaiba ng microprocessor and the microcomputer. Ayan. Next. Punta naman tayo dito sa microprocessor based system with bus architecture. So yung mga microprocessor natin, meron niyang tinatawag nating bus. It is a group of lines used to transfer bits between microprocessor and other components of a system. No? Yan. So dito, yung ating microprocessor, binibigyan natin siya ng command na para i-execute. Then babasahin niya yung instruction na yon. One instruction at a time. No? Instruction 1, then execute. Instruction 2, execute. So hanggang ma-send niya yung results output device. So may mga terms tayo na ginagamit or phrases to describe yung operation ng mga microprocessors. Like for example, itong read, interpret, and perform. So ibig sabihin yan, yung microprocessor natin will read the program, it will interpret yung instruction, and then perform according dun sa interpretation niya. Then we also use these phrases: fetch, decode, and execute. So the microprocessor will fetch the command, it will decode the command, and then execute. So yan yung mga terms na ginagamit natin. Okay? So let me just define ano yung mga parts na nandito. No? We have here in this side yung ALU or the arithmetic logic unit. This is the area of the microprocessor where various computing functions are performed on data. So dahil nga arithmetic and logic unit siya, anong ginagawa niya? It performs yung mga arithmetic operations such as addition, subtraction, kasama na rin dyan yung mga logic operations katulad ng AND or exclusive OR, mga ganon. Okay? Then we also have here yung ating register array. Itong register array, area siya sa microprocessor na kung saan nandun yung mga various registers na na-identify. Na-identify natin yan na through letters. Register B, register C, D, E, H, and L. So these registers are primarily used to store data temporarily. No? So dyan lang muna yan ilalagay, and then pag kailangan na siya i-access base dun sa pagkaka-execute ng program, dyan kukunin ni ALU or ni microprocessor. Let's say, nakalagay yun sa register B. Pag sinabing kunin sa register B, kung ano yung laman ng register B, yun yung kukunin niya. So, this register array are used to store data temporarily during the execution of a particular program dun sa microprocessor. Okay? So, next, sa loob din ng microprocessor, we have the control unit. Okay? The control unit provides the necessary timing and control signals para hindi magkagulo or makontrol natin yung flow ng data between the microprocessor, the memory, and the peripherals. Now, the question is, what is the relationship among the programmer's instruction, the ALU, and the control unit? So, sa loob ng microprocessor, meron tayong tinatawag na full adder circuit. Okay? Ano ang ginagawa ng full adder circuit? Kung maalala ninyo sa subject niyo ng Digital Electronics 1, a full adder circuit can be designed with registers, logic gates, and a clock. So, mag-initiate yung clock. Mag-initiate siya ng adding operation. And then, similarly, the bit pattern of an instruction initiates the sequence of clock signals. So, it activates the appropriate logic circuits dun sa ating ALU, and then mape-perform niya na yung tasks. So, ang tawag natin dito, microprogramming. So, during the design stage ng microprocessor, yun yung ginagawa. So, in many ways, parang kumbaga similar yan kung paano tumatakbo yung utak natin. So, sa pagkabata, natututunan natin pag sinabihan tayo na sit, uupo tayo. Yung physical motions natin, kumbaga natututunan na natin. Pag narinig natin yung salitang sit, automatic. Yung brain natin will activate a series of actions para dun sa muscles natin tsaka yung bones natin para umupo tayo. So, ganun din sa microprocessors. katulad din yan sa pagbibigay ng instructions. So, yung ating microprocessor is initiated by these microprograms. Okay? So, ano pa yung part natin dito? I.O. Nakikita ko dyan yung I.O. So, ito yung pinaka-third component natin dito sa microprocessor-based system with bus architecture. So, yung third component natin dito is the I.O., yung input-output. Napaka-importante nito dahil it communicates dun sa users, di ba? And the microprocessor. Dahil yung microprocessor natin, ang naiintindihan lang yan, 0 and 1. Pero yung user, yung tao, ang naiintindihan niya, mga letters, information. So yung I.O. includes two types of device, yung input and output. Ang tawag natin dito sa mga devices ng input and output, they are also known as peripherals. Pakitandaan. Katulad ng yung mga input, sample ng mga input, keyboard, switches, yung mga analog to digital converter. Sa lahat ng outside world to the microprocessor that enters data doon sa microprocessor. Ang tawag natin doon, input. So, usually, sa experiments natin or sa exercises natin sa microprocessors, we are going to use a keyboard to enter yung mga hexadecimal na command sa circuit or sa microprocessor. So meron tayong hexadecimal keyboard na gagamitin. Meron niyang 16 na keys or pindutan, 0 to 9 and then A to F. Then meron din yung mga additional function keys to perform yung mga some additional operation tulad ng data storing and executing programs. So, yan yung isang input, example ng input. Yung output devices naman, so transfer data from the microprocessor palabas naman papunta sa users. So example natin yung mga LED, mga display. Then pwede ring plotter or magnetic tape or digital to analog conversion. So typically, single board microcomputers and microprocessor based products katulad ng example? Microwave. They include LEDs and 7-segment displays para mas maintindihan ng user kung ano yung nangyayari sa microprocessor or sa product, no? So ano pa yung nakikita ko dito? I can also see system bus. Ano ba yung system bus na yan? The system bus is a communication path between the microprocessor and the peripheral. So ano yan? It is nothing but a group of wires to carry bits. So daanan siya, no? And then ano ba? In fact, maraming buses meron tayo sa microprocessor systems. Pero hindi muna natin yan i-discuss ngayon. Sa ngayon, i-define lang natin siya as system bus. Memory. Lastly, memory. Meron tayong dalawang section in this case, no? Meron tayong tinatawag na read-only memory and read-write memory, no? Ito yung ROM or ROM, read-only memory, and then yung isa naman, read and write memory. So, medyo familiar tayo dito, no? Para ma-execute natin yung mga programs, yung microprocessor reads the instructions and data from the memory. So, yung ROM or yung read-only memory, ginagamit natin yan to store programs that do not need alterations. Forever na siyang nandun, no? Yung monitor program ng isang microprocessor, usually nasa ROM yan. Hindi kasi yan natin magagalaw. So, itong monitor program interprets the information entered through a keyboard and provides equivalent binary digits to the microprocessor. So, dahil monitor program siya, kailangan nasa ROM siya. Hindi siya pwedeng mabago. kung mabago siya, hindi maintindihan ng microprocessor yung or maaring magkamali ng pagka-execute si microprocessor. On the other hand, meron din tayong read-write memory. Isang din term na ginagamit natin dyan is user memory. So, itong read-write memory, it is used to store user programs and data. So, lahat ng pinapasok natin sa keyboard, papunta sa monitor program na data o user data or programs, instructions, papasok yan sa read-write memory. Kasi dito kukunin ni Alu and the microprocessor yung mga data na kanyang i-execute. So, memory has two, in this case, the memory has two sections. The read-only memory and the read-write memory. Alright? So, next, punta naman tayo, i-discuss natin yung instruction sets and computer languages. Yan. Sabi nga natin kanina, microprocessors recognize and operate in binary numbers. However, each microprocessor has its own binary words. Kada microprocessor, pwedeng iba yung interpretation niya doon sa mga digits. So, itong mga word na ginagamit ng microprocessor, yun yung naiintindihan niya. So, it recognizes yung word. Then, a byte is defined as a group of 8 bits. Pag sinabi naman nating nibble, so 4 bits naman yun. So, dapat ito ay double B. Sorry. Yan. Define lang natin dito. So, kada machine or microprocessor has its own set of instructions base sa pagkakadesign ng CPU or nung mismong microprocessor. So, to communicate with the computer, so, yung programmer or yung user must give instructions in binary language. So, ang tawag natin doon, machine language. Yun yung language na naiintindihan ng microprocessor. Ito yung mga 0 and 1. So, ang tawag natin dyan, machine language. So, dahil 0 and 1 yan, napakahirap yan intindihin para sa mga tao. Tulad ng mga programmers na kung magsusulat tayo in 0 and 1, napakahirap niyan intindihin. Kaya, yung mga programmers, they write programs. We called it assembly language programs. No? Meron tayong machine language, ito yung mga 0 and 1, and then meron din tayong assembly language. So, itong assembly language, so gumagamit na tayo ng words. Okay? Pero, itong words na ginagamit sa assembly language is specific to a particular machine. Okay? And they cannot be transferred from one machine to another. So, yun yung disadvantage ng assembly language. Let's say, tulad ng BASIC or C++ or Fortran. So, may mga assembly language na para lang sa specific microprocessor. No? So, yun ang disadvantage. So, paano ba? To circumvent this limitation, meron din tayong tinatawag na high-level languages. May mga programs na device, no, na machine independent. Ibig sabihin, kahit anong machine pa yan, pwede siya mag-operate doon using this language. So, ang tawag natin doon, high-level languages. Okay? So, meron tayong machine language, meron tayong assembly language, and high-level languages. So, dito sa discussion natin ng microprocessor, sa ano tayo, although dadaanan natin lahat yung languages na yan, we will focus on the machine language and the assembly language. No? So, ayan. Ano ba yung machine language na yan? So, itong machine language, ah, ang ginagamit natin na term is instructions, no? So, an instruction is a binary pattern entered through an input device in the memory to command the microprocessor to perform that specific function. So, yung instruction is a binary pattern. Kaya, yan ay machine language. Okay? So, the 8085 microprocessor has 246-bit patterns amounting to 74 different instructions. So, ang tawag natin dun sa 74 different instructions, they are called instruction set. Oh, by the way, itong 8085 microprocessor will be the focus of our topic, no? So, madali kasing i-program tong 8085 tapos ano siya, it represents hindi lang yung components or structure, architecture ng mga microprocessor, pero pati yung mga advanced na mga microprocessors, pwede rin niya i-represent. So, dito tayo sa 8085. Okay? So, an instruction is written in hexadecimal code and entered in a single board microcomputer. So, itong hexadecimal, ang tawag na natin dito is yung ating assembly language, no? Dahil gumagamit na tayo ng hexadecimal. So, for example, meron tayong machine language 00111100. Ang equivalent niyan sa hexadecimal is 3C. O yung H nilagay ko lang dyan para masabi na hexadecimal. So, this is an example or sample instruction that increments the number in the register called accumulator by 1. So, ito palang 3C is an instruction pala yan, no? Na mag-a-add sa laman ng accumulator ng 1. So, command siya dun sa 8085. Alright? So, ganun pa man, even though yung mga instructions can be written in hexadecimal code, medyo mahirap pa rin yun, no, para sa atin. Dahil hindi naman natin makakabisado yan. Tapos, let's say, we work on many microprocessors. Mahirap kung magkalito-lito tayo pagka iba-iba yung paggamit nila ng mga hexadecimal numbers. So, dahil doon, yung mga manufacturers, they devised yung symbolic code. They call it mnemonics. Yan. Yung mga mnemonics, they consist of letters that suggest the operation to be performed by that particular instruction. So, for example, meron tayo dito. 00111100 sa hexadecimal equivalent yun sa 3C. Pero meron din siyang mnemonic that is INRA. So, yun yung mnemonic niya. Dito sa INRA, medyo naiintindihan na natin ng kaunti, no? Kasi yung INR, it represents or suggests that we increment, no? We increment, yung A naman is the accumulator. We increment by 1 yung ating accumulator. Ito medyo naintindihan na natin. Kumpara sa 3CH and 00111100, right? So, ang tawag natin dito, mnemonics. Okay. Pa ba? So, yung mga programming languages natin that are intended to be machine independent, ang tawag natin doon high-level languages. No? Ibig sabihin, they can be operated in various machines or microprocessors. Okay? Although, meron din tayong tinatawag na Um, Meron din tayong tinatawag na compiler or an interpreter. So, ang trabaho ng compiler o kaya ng interpreter, they translate a source code ng tao or programmer into a machine language compatible with the microprocessor being used in the system. So, aside from having machine language, meron tayong assembly language, then meron tayong high-level languages. We also have this compiler and interpreter, no? So, ano ba yung compiler? Ang trabaho ng compiler and interpreter is, 'di ba meron tayong mga English words. Hindi naman niya naintindihan ng microprocessor. So, paano siya naintindihan? Merong program na compiler and interpreter na ang trabaho nila is mag-accept ng mga English-like statements as inputs, and then ah, sila yung pa-process nitong tinatawag nating source code. Yung source code, yan yung mga English-like tulad ng printf, mga gano'n. Ah, Sila yung magpa-process or mag-i-interpret kumbaga dahil, let's say sumali ka sa pageant sa Miss Universe and iba yung language mo. Meron kang interpreter, 'no, to translate yung source code papunta sa language na naiintindihan mo, okey? So, ang tawag natin dun sa machine language na naging output ng isang compiler or an interpreter, ang tawag na natin dun object code. So, each microprocessor, kailangan meron siyang sarili niyang compiler or interpreter. So, ang primary difference lang ng isang compiler and interpreter is kung paano niya tina-translate yung commands. Sa compiler, babasahin niya muna yung lines or yung instructions or ng source code. Kumbaga bubuuin niya muna tapos iintindi niya maigi bago niya ita-translate. So, yun yung trabaho ng compiler. Kumbaga ang dami mo munang sinabi in Chinese, tapos nanamnamin muna ng interpreter mo or ng compiler mo, and then i-interpret niya yon accordingly at gagawin niyang object code, right? So, sa interpreter naman, ang ginagawa ng interpreter, habang binabasa niya yung instruction line by line, tina-translate niya. So, regardless of the output on the future instructions, kada line i-interpret niya. Kaya siya tinatawag na interpreter, no? So, yun ang difference ng compiler and interpreter. But they are both high-level languages, okay? So, yan. Medyo lumalalim na ng kaunti yung ating discussion papasok sa mga microprocessors, 'no. Importante na malaman natin 'tong mga languages na 'to, kasi gagamitin natin sila in the future, 'yan. So, dahil nasa microprocessors na rin lang tayo, napag-uusapan din diyan yung operating system. So, the operating system, ito yung pinakamalapit sa hardware and the application programs. Yun yung mga pinakamalayo, 'no. So, yung interaction between the hardware and the software, ang nagma-manage diyan is the operating system. So, the operating system actually is a set of programs na isang computer. So, nakapasok din yan sa ROM. Siya yung nagma-manage ng interaction between hardware and software. So, it oversees lahat ng operations ng isang computer. So, siya rin yung nag-i-store ng programs sa disk, and then responsible yan for storing information dun sa disk and for the communication between the computer and its peripheral. So, yun yung trabaho ng operating system. So, it is a set of programs para mag-manage ng operations ng isang computer. Okay? Application. So, malapit na tayo matapos. So, we have here a temperature microprocessor controller temperature system. Base dun sa mga concepts na diniscuss natin kanina, tignan natin 'tong system na 'to. So, microprocessor control temperature system. So, ang expectation natin dito sa system na 'to is that meron tayong mga temperature sensors that will read the temperature in a room and will display the temperature dito sa LCD or liquid crystal display, no? Um, it will also turn on the fan kung yung temperature natin is above a set point, and then it will turn on a heater kung mababa naman sa set point. So, ito yung ating mga outputs like yung fan, heater, and LCD. Yung input natin is yung temperature sensor, right? Discuss natin yung mga components niyan para mas maintindihan natin yung microprocessor system. So, punta natin yung system hardware. In addition dun sa microprocessor and the memory, kailangan din natin ng mga input and output devices. So, kailangan natin ng temperature sensor, na diniscuss na rin natin, as input device para ma-sense natin yung room temperature. And then, kailangan din natin ng tatlong output device, fan, a heater, and an LCD or display. So, ito yung hardware natin. Dito sa example din natin na to, gumamit din tayo ng 8085 microprocessor with a system bus. So, yung processor natin will read the binary instructions from the memory and will execute these extra instructions continuously, no? One instruction at a time. It will read the temperature, display it in the LCD display panel, will turn on or will turn off yung fan natin and heater base dun sa temperature na binabasa niya. So ganun yung programming ng 8085 microprocessor in this particular example. We have memory. Meron tayong dalawang types ng memory dito sa example natin. Read-only memory. So dito nakalagay yung program, yung monitor program na responsible for providing the necessary instructions to the processor to monitor the system. So permanent na yan, hindi na natin yan pwedeng baguhin. And then meron din tayong read-write memory na dito na i-store yung reading ng temperature. Okay? So temporary lang naman. So dito siya na i-store. Then meron din tayong tinatawag na component diyan as input. Meron tayong diyang input port 1, di ba? So, kailangan natin yung input port 1 and then meron din tayo diyang analog to digital converter. Dahil yung binabasa natin sa labas is an analog signal and obviously yung ating microprocessor is capable of handling binary digits, di ba? So, yung signal natin must be converted into digital bits, 0 and 1 din. So, kailangan natin yung analog to digital converter to perform yung conversion function na yan. So, kaya nilagay ko rin yan dyan as a part or component ng ating system. So, usually, sa mga microcontrollers, kasama na siya. Pero sa mga microprocessor-based systems, hiwalay na circuit yung AD conversion. Okay? Next, we also have yung mga output ports natin dyan. No? Port 1, output port 2, output port 3. Then, of course, dahil meron niyang microprocessor, it runs it runs the system using a monitor program or system software. Generally, itong program na to is divided into subtasks and written independently into modules. Tapos ini-store yan sa ROM or sa EEPROM. So, pag naka-reset yung system, the microprocessor reads the binary command from the first memory location ng ROM na yon. And then, mag-a-add ng 1 na mag-a-add dun sa timing and then babasahin niya yung location dun sa mga susunod na memory. So, ganun yung function nitong microprocessor controller temperature system. So, yan. So, that's it. To summarize lang, mabilis lang, we discussed yung basic microprocessor configuration. Meron tayong tinatawag na CPU, ALU, diba? And then control unit. We also discuss yung memory, input and output. Then yung mga scale of integration, diba? Diniscuss din natin yan. Ano-ano yun? Yung SSI, MSI, LSI, hanggang giga. Then we also touched on microcomputers. Yung difference ng MPU and MCU. Okay? Meron din tayong, diniscuss din natin yung bus. Tama ba? Then meron tayong ROM and read, write memory. Differentiate din natin yan. Then yung mga common terms sa computer language, diniscuss din natin like binary or bit, byte, yung group of 8 bits. Nibble, it is a group of 4 bits. Word, group of bits the computer recognizes and processes at a given time. We also touch on or define yung instruction. Instruction is a command in binary form, right? Dahil binary yan, hindi yan natin naiintindihan, so gumagamit tayo ng mnemonic. Yung mnemonic is a combination of letters that suggest a particular operation ng isang instruction. No? So, pag collection of instruction na yan, ang tawag na natin dyan is program. Okay? So, wrap up naman yung mga language we touched on machine language. Ito yung mga binary. 01, 01. Ito yung naiintindihan ng microprocessor. Okay? And then we level up assembly language. Medyo gumagamit na tayo ng mnemonics dito sa assembly language. Then another level, tinatawag nating low level language. Itong machine language and assembly language are considered low level languages. So we also touch on high level language. So medyo ito may konting communication na to sa tao. So independent na siya given yung ating machine or microprocessor. So high level languages. And we also touched on compilers and interpreter. We dinifferentiate natin yan kanina kung paano nagwo-work ang isang compiler at ang isang interpreter. We also discussed on assembler. No? So assembler is a computer program that translates an assembly language program from the mnemonic papunta sa binary machine code. Alright? Then, ano pa ba? Discuss din natin yung operating system. So, this is a set of programs that manages yung interactions ng hardware and software. Okay? And we had an example, diba? Yung temperature controller using microprocessor as its CPU. So, yan. Looking ahead, on the next discussion, we will discuss na yung assembly language ng 8085. Then medyo may konting programming na yan. Okay? So with that, maraming salamat sa pakikinig and hopefully meron kayong natutunan dito sa lesson natin on microprocessors, microcomputers, and assembly language. Maraming salamat. Thank you. Keep safe. Bye-bye.